Prachi, my voice is clear?
Yes, sir.
Okay. Okay, screen is visible to everyone.
Yes, sir.
Okay. Okay, last class I discussed about the pin diagram of 8051 microcontroller. Okay, and today I discuss about the architecture of 8051, architecture of 8051 microcontroller. So this is the architectural diagram of 8051 microcontroller. It has total number of pin is 40, and some pin are dual purpose of function, and the total structure of 8051 microcontroller is that first block is that system timing, system interrupt, timer buffer, and memory control. Means this is the control of all the operation through this part of this block. So control signal are or status or the system interrupt signal are EA, ALE, PSEN, Xtal, Xtal2, reset, PCC, ground. Okay, so this is our control block or timing block of the 8051 microcontroller architecture. And second block from lower side, the second block is the byte address. And in another thing, in 8051 microcontroller, there are a 4 register bank. The total number of register bank is 4, which are register bank 0 or R0. This is the R0 or register bank 0, register bank 1, register bank 2, register bank 3. So what is actually the function of register bank? And another is the byte or bit address in the register or internal RAM structure. So in register, every register bank actually it is the basis of, suppose in our book, what is the if chapter 1, chapter 2, chapter 3, just like here the register bank also same. Register bank R0 means R0 has some page number. Suppose in books, example of any book, the chapter 1 contains the page number 1 to 30, then chapter 2 contains the page number 31 to 60. Okay, as same in register bank or register address or register bank address, there are each range of the each registered bank, each registered bank. Okay, some are starting from register bank 00, starting from 00 to 7F, then FF to some value और 80 to some value, ऐसे करके करके ये जो एड्रेस इसका रहता है just for page. Okay, and you see here the next block is the this called special function register. The register which are called in microcontroller is special function register, because it has the special function. Means, just for example of pcon. Pcon means this is power control. This is power control. So the special function of this pcon register is control the power of the microcontroller. SBUF means serial buffer. Serial buffer. It can be controlled, or it can be through this special purpose register. The data is serially to the another data, and the name is SCON, means serial control. This control the data flow in serial mode. Okay, TCON, timer mode. So these are the special function register. I explain each of the special function register with a example later one. Okay, and then T mod is the timer mode. Then TL0 and TH0 means we are all know that in 8051 there are two timer register. Each are 16 bit. Which is denoted by TH0, TH1 and T0 and T1. T0 and T1. But in this case here the TL0 and TH0 means this is the lower 8 bit of the 16 bit, and this is the higher bit or higher timer register of 8 out of 16 bit, which is this is actually TH is 8 bit and TL is 8 bit. So total is the 16 bit. Total is 16 bit. At same the T1 also furtherly classified divided into two, which is TL1 is the 8 bit and TH1 is the also 8 bit, but TL1 is the lower 8 bit and TH1 is the higher 8 bit. Okay, and here you see the microcontroller. Here is the ROM. And this is ROM, and this is the special function register RAM, and this is PSW or program status port, and this is our main unit or arithmetic unit which perform the logical and arithmetic operation, which is AL unit. Has two part, one is A, another is B, because these two is combined operation is performed using these two register, and these are connected. This is the PC is, you see here the bit address is 16 bit. Okay, which is here is data pointer register, and data pointer register is furtherly divided in DPH, means data pointer high, data pointer low, means this can be point the lower 8 bit of the 6 out of 16 bit, and this can be point 16 bit. Next one is the PC. We all know about the function of PC or program counter. The program counter actually is fetch or the point out the next memory location where data byte is to be fetched. Okay, where data byte is to be fetched. So this is our architectural part, and this is the four latch. You see here the all the port are connected through this memory control signal, and also the latch. All the latch is connected through a PC, DPTR, and register part. And here is the two signal. One is go from PC to DPTR and RAM ROM, and another from arithmetic logical unit. This can be is latch 1, latch 2, latch 3, latch 4. So each latch is connected to it. We are all know that in 8051 there are number of port is 4, and each port is 8 bit, or means 8 IO input output lines. 8 input output lines, and the port 0 is A0 to A7, D0 to D7, and all are Also it is input output lines. These are the input output lines. And how many number of lines? Total number of lines is 8. And port or is the simple IO lines, which is IO. And port 2 has IO lines including the higher order address, which is A8 to A15, which is A8 to A15. Okay. So this is the port, and last port is the port 3. The port 3 also the eight lines. So port 3 is consists of the IO port and interrupt counter and serial data and read write signal. So this is the architectural view and architectural block diagram of 8051 microcontroller. So this is our system timing, system interrupt, timer buffer data or and memory control, and which the pins are VCC, GND, reset, extal 1, extal 2, PACN means and ALE and EA. And this is the register bank, which is total number of register bank is 4, and this is our special function register, and this is the latch, and this each latch connected through a port 0 and port 1, port 2 and port 3, and here is the internal ROM of the microcontroller, and this is the special function RAM or special function register RAM, and this is our ALU or arithmetic logic unit with a and contains with A and B register, and this is our PC and DPTR. Okay, DPTR. So स्लाइड चेंज हुआ है? हेलो हेलो
No, sir.
Just one. अब चेंज हुआ?
Yes, sir.
Okay.
Yes, sir.
So we study about the 8051 microcontroller. Now the features of 8051 microcontroller, it has ROM of 4 kilobytes. It has ROM of 4 kilobytes and RAM is 128 bytes. And I already told there are two timers which is denoted by T0 and T1. And total number of IO pins is 32, which is total number of port is 4, P0 to P3, and each port are 8 lines, and on serial port and total number of interrupt source is 5, which includes of 2 internal and 3 external interrupt, which includes the 2 internal interrupt and 3 external interrupt. So this is the features of 8051 microcontroller. This is the features of 8051 microcontroller. Now the various family, now the comparison of the 8051 microcontroller family members is that in 8051, 8052, 8031. So 8052 has some small changes. What is the small changes? In 8051, there are 4K is ROM is 4K, on-chip program space in byte is 4K, but in 8052 is 8K and 8031 is 0K, and RAM is 51. In case of 8051, RAM is 128, and in 8052 256, and 8031 is 128. And another is that timer 2, 8051 and 8031 both are timer 2, but in 8052 the timer is number of timer is 3, and IO pins are same in all case. The total number of IO pins is 32, and also serial port is also 1, and total number of interrupt source is 8051 is 5, 8052 is 8, and 8031 is 6. So this is the some comparison of 8051 family members. some just for see here, another microcontroller from Atmel, which is called port as a 8951 89C51, okay, 8951, and 8951, and the very speed from Atmel is that our clock frequency port is that, or the operating frequency is, or the speed is 12 megahertz, 12 megahertz, and all are packing in DIP plastic, and it is used for commercial purposes. 8951 is used for commercial purpose. I already covered the pin description. Now today I discuss about the port. Now this slide is showing to everyone port 0. The port 0, only the port 0 pins may serve as an input output, and when it is also serve as a bidirectional lower order address and data bus. I already said previous class, but I again repeat this. Okay, तो P0 मीन्स P0 में जो पिन डायग्राम को थोड़ा याद करो और आर्किटेक्चर में देखो, ये जो है मेरा P0 pins may be served as a input output, basic input output port, and also it is used as a bidirectional multiplex address data bus for external memory. And to configure as an input port, the logic on must be written to the corresponding port 0 by port 0 and latched by program, and it is used as a data bus during the internal EPROM programming. So how the port 0 is connected? So this is the connection of port 0. So P0, P0, these are the port 0, which is all are, this is the our supply VCC, and through A80 10K resistance, and the output as go through the port 0 with a pull up register, port 0 with a pull up register. So this is the simple pull up register with of port 0. And P1 and P2 port, P1 and P2 port may be used as an input or output port, and they does not require external pull up register, but P2 supply the, क्योंकि P1 in generally simple input output, but supply the higher order address bus. Only P2 supply the higher order address bus for external memory or input output device. P2 supply the higher order memory, sorry, P2 supply the higher order address bus for external memory or input output devices. So this is the P1 and P2. Now P3 may be served as a basic input output port, and also it is served as a different function. Just for RxD, this is serial data input, and serial data input is used for SBUF, means this here SFR is a special function register. SFR is special function register. So these are the our special function register, and this is the port 0 pin, which is P3.0 to P3.7. So P3 port generally used as a basic input output port, and also it is altered the P3 as function in this table. The first P3.0 is the RxD pin, which is serial data input, and it is used or
जी सर
हाँ बोलो
सर ये स्लाइड चेंज नहीं हुआ है सर
just 1 second. अब changes हुआ है?
हाँ सर हो गया.
Okay, again I repeat this. Actually, P3 may be as a used simple input output port, and also it is used as a special type of function, just or special purpose use, just for the see here the table. क्योंकि just जब पिन डायग्राम हम लोग शो किए थे, देखो उसमें सिंपल आयो था और उसके साथ राइट हैंड साइड में RXD, TXD, INT ऐसे करके पिन था. एज सेम द पोर्ट जीरो के में क्या था, मेरा सिंपल इनपुट आउटपुट तो था ही, उसके साथ वो एक्स्ट्रा जो फंक्शन किया था वो एज ए इट इज यूज्ड एज ए लोअर ऑर्डर bidirectional address data bus multiplexing in case of port 0. But in here the P3 ports are the some function which is the P dot 0 is the RXD pin, which is the serial data input, which is the serial data input, which is used as per using by SFR register, which is SBUF, which is called serial buffer register or serial buffer register or serial buffer. And P3.1 is which is TXT, which is serial data output, and it is also used as a SBUF register for SBUF register. Next one is the P3.2, which is and P3.3, which is two interrupt. I previously says that in 8051 there are two internal interrupt and three external interrupt sources. So two internal interrupt is denoted by INT0 and INT1. So this is the external interrupt 0, external interrupt 0 or external interrupt 1, which is TCON 1 and TCON 3. And then timer mod, this is T mod is the special function register, which is called timer mod register, and this is which is T0 and T1 is the port P3.4 and P3.5, which is the two timer register are used, which is the external timer 0 input and external timer 1 input. And another two function is that external memory write pass and external memory read pass, which these two, which is P.3, P3.6 and P3.7, which is WR and RD. So your WR is the external memory write pulse signal and RD bar is the external memory read pulse signal. So this is the function of pins of port 3, which is RXD, TXD, INT0, INT1, T0, T1 and WR bar and RD bar. The first one is the serial data input, serial data output, first and second. And these two are as a special function register, as a SBUF register with function with these two pins. Next two is the timer control, which is the external interrupt INT0 and INT1, which is the external interrupt 0 or external interrupt 1, and which is the special function register used here as a TCON 1 and TCON.3. And next one is that the T0 and T0 and T1, or the external timer 0 input and external timer 1 input, which is T mod, and these two is the T mod is the timer mode. And another left two is that WR and RD, which are external memory write pulse signal, and another is external memory read pulse signal. So this is the port 3 function in 8051 microcontroller. Next is register in 8051 register, which is A and B. Previously you see the architecture ALU connected in a two register, which is called CPU register, which is A and B. A and B two register, which are the in case of 8051, these two are called CPU register. Then another is that program counter and DPTR, which is data pointer register. DPTR is data pointer register. Program counter and data pointer. And another is that flag and program status odd, which is PSW. Flag and program status odd, which is PSW, and internal RAM and some special function register, and also it contains with a 8-bit stack pointer. 8-bit stack pointer. So these are the register of 8051 microcontroller. And okay, so first is A and B CPU register. What is the function of A and B CPU register? Slide change हुआ है? Hello.
Yes,
A
sir.
and B CPU register शो कर रहा है ना सबको?
Yes, sir.
Okay. So you all know about the 8051 microprocessor, that 8085 microprocessor. There have no direct multiplication instruction. यही ना, क्योंकि हम लोग पहले भी क्लास में बोले हैं और ऐसे जब प्रोग्रामिंग भी किए थे, मल्टीप्लिकेशन ऑफ टू 8-bit नंबर इन केस ऑफ 8085 microprocessor, there have no direct instruction for multiplication or division, but in 8051 there are direct instruction for performing the multiplication or division type of operation. So in first of all, in 8051 microcontroller, two CPU register, one is A and another B. So what is the function here to the A register? So we all know about the A actually accumulator or A register. It is used for many operations including addition, subtraction, integer, multiplication, division, and logical operations. So A register are used for many kind of operation including addition, subtraction, integer multiplication, division, and logical operation. And also the A register is also used for all data transfer between 8051 and any external memory. So another function of A register is that it is used also for data transfer between microcontroller and external memory. Now what is the function of B register? The B register is used with a register for multiplication and division operation, and it has no other function other than as a location where data may be stored. So B register generally used for multiplication and division operation, and also it is the function for other than as a location where the data, it is identify the location where the data may be stored in 8051 microcontroller. So first of all, here all about the clear about A and B register function in 8051 microcontroller. Next is the two register, which is one is DPTR and PCR. DPTR and PCR. So first of all, program counter and DPTR both are 16-bit register, means PC and DPTR are two 16-bit register, and these two are actually used to hold the address of a memory. The PC and DPTR used to hold the address of a memory, and PC is used to hold the address of next memory location which is to be execute. जो डेटा को execute करना है उस डेटा को आइडेंटिफिकेशन इंडिकेट करते हैं. And PC has no internal address. Now what is the function of DPTR, which is data pointer register? The data pointer register is made of a two 8-bit register named as a DPH and DPL. So DPTR is actually used to hold the memory address for internal and external code memory, and also it is used as a external data memory. So main function of the DPTR is that it is used to hold the memory address for internal and external code memory, internal and external code memory, and external data memory. So all about the clear about the PC and DPTR function. So DPTR, again I repeat the function of DPTR. DPTR actually used for holding the memory address for internal and external code memory access and also external data memory access. Okay. Now the PSW. Now the PSW. Actually, PSW or program status sort is an 8-bit register, and PSW contains the 4 map flag. 4 map flag, which is a user program flag, is F0, and register select bit is RS1 and RS0. Just and PSW register is a bit addressable, so all the flag can be set or reset by the programmer at will, and the PSW structure is shown in below, which is the 0 to 7 bit, which is CAY, AC, F0, RS1, RS0, OV, and no, number 1 is not, and P0 is the P. This is the program status word and flag block, which is carry, auxiliary carry, F0 and F0. So F0, the F0 is the user program flag. User program flag is F0 and register select bit is RS01 and RS02. RS01 and RS02. So flag bit 1, okay, flag bit, the flags are 1-bit register, which is group of inside the PSW and PCON, inside the PSW and PCON. The flags are provided to store the result of a certain program instruction. The 8055 has 4 math flags, which is include of the carry flag, auxiliary carry flag, overflow flag, and parity flag, and 3 the user flag, which is named as a F0, GF0, and GF1. GF0 and GF1, and GF0 and GF1 are stored in PCON register. Here the PCON register is the special function register, which is power control register, So we all about know the how the carry flag set, auxiliary carry flag set, and overflow set, and parity flag also set. New here the new 2 flag is the name is the F0 and GF0 and GF1. But in GF0 and GF1 are stored in PCON register, which is called special function register, and the flag bit are 1 register, which is a group inside the PSW and PCON. The carry flag is, we all know about the when carry flag set. When the carry is generated from bit D7, then the accumulator, then it is the arithmetic or jump, rotate, or the Boolean instruction. So auxiliary carry flag is set where there is a carry generated from 3rd bit to 4th bit of the accumulator, then it will be set, and this is happened only when the BCD operation is performed. Next, the parity flag set, when it says on the set to 1 when the number of 1 in A is odd and even. अगर odd होगा then set, अगर even होगा तो reset. And there are 3 user flag, which is general purpose flag, which can be set or reset by the programmer at it. Means 3 general purpose flag register, which is can be set or reset according to depends on the programmer. So which 3? First one is the F0, then GF0, GF1, and here is the RS0 and RS2 are the register bank. RS0 and RS1 is the register bank select bit, which are used to select the specific bank of internal RAM. Because I previously says that there are number of bank is 4, which is register bank 0, register bank 1, register bank 2, register bank 4. So in these two means RS0 and RS1 are two registered banks. These are used actually select the registered bank means which bank is selected for particular operation of the RAM location. This can be identified by using 2 bits. So RS0 and RS are the two register bank select bits which are used to select the specific register bank of internal RAM. So when which bank is select, it will be show the just this table. When the both value means RS0 and RS1 both are 0, then the bank selection is R select register bank is 0 means bank 0 is selected. If 0 1, then select the bank is 1. Okay, if 1 0, then the bank 2 is selected. If both value is 1, so bank 3 is selected. So bank 3 is selected. Okay, so when which bank is selected, it depends on the value of R0 and RS1. R0 and RS1. स्लाइड चेंज हुआ है, जो 8051 फ्लैग बिट्स एंड द प्रोग्राम स्टार्स लिस्ट है, ये शो कर रहा है ना सबको? हेलो हेलो, स्लाइड चेंजेस हुआ है? हेलो
Yes, sir.
ओके, तो ये समझ में आ रहा है क्या नहीं? इस ऊपर ऊपर चला जा रहा है, क्या बात है? और घर में बैठ के सिर्फ खा रहे हो और सो तो नहीं रहे हो ना? पढ़ भी तो रहे हो ना कुछ, ना वो भी नहीं कर रहे हो? पढ़ाई चल रहा है कि नहीं चल रहा है? तब कोई आंसर नहीं है, यही तो सबसे बड़ा बात है। हम इतना ही इनपुट दे दे, आउटपुट 0 ही आएगा, मतलब गेन नेगेटिव। जो भी छोड़ो, जस्ट यही लास्ट स्लाइड है आज का। तो एक्चुअली PSW bits and PSW register flag bits and the PSW register. So PSW, it is a 8-bit wide, but is use only the 6-bit. Is only use the 6-bit. There are 4 condition of flag, which is CY, AC, P, and OB. OB actually overflow, and 2 user defined flag, which is PSW1 and PSW5, and 2 register bank selector, which is RS1 and RS2, which is RS1 and RS2. So this is the CY if PSW.7, AC PSW.6, F0 is the PSW5, which is available to user for general purpose using, and RSW1 and RSW2, which is the register bank selection, and overflow is the PSW.2, and last is the parity. Parity flag is set or cleared by hardware each instruction cycle to indicate odd or even number of the 1 bit in accumulator. Means accumulator में even number है ना odd number है, ये identifies it can be identified by this parity flag bits. Now see this table. Here is the RS01 and RS1 and RS0, and this is the registered bank, and this is the range of each bank. So first bank of registered bank 0 or bank 0 is the range is 00 to 07 hex. It is the of RAM location, मतलब RAM का जो रेंज है वो रजिस्टर बैंक का जो रेंज है वो 00 से स्टार्ट होगा, एंडिंग होगा 07 में. नेक्स्ट रजिस्टर बैंक 1, register bank starting from 08 and ending is 0F, ending is 0F. And next one is register bank 2, which start from 10, means F के बाद 1 ही होता है, पता है ना, हेक्साडेसिमल नंबर सिस्टम है, तो 10 से स्टार्ट होता है और एंडिंग इज दैट 17, and last one is 18 and ending is 1F. Okay, so is there any doubt or any kind of question? Please ask me. Is there any kind of doubt or any kind of, please ask me. Okay. So I think everyone understood very much clearly. Okay. So I end the today's class. Okay. And next class is tomorrow, and I will adjust the class of previous class due to network problem. I cannot take the class of yesterday class, so I can be taking another class on Saturday. I will share the schedule of this class. Okay, previously. Okay, so end the class.